for the newest and richest experience being offered now. A spirit of welcoming is a sense of humanity and a pledge to spread peace and happiness. I now request Dr. M. Ramesh, Vice Principal KIT, to welcome everyone.
Very good morning. It gives me great pleasure to welcome you all most cordially for the virtual inauguration of this webinar on multi and interdisciplinary approach to innovate academic project ideas and opportunities for engineering students, jointly organized by KIT, Technoloty Institute of Technology and NDRF, National Design and Research Forum, in association with Institution Innovation Council, Government of India. KIT was established as an affiliated college of Anna University in 2008 by Vijayalakshmi Palanichami Charitable Trust and offers 8 different BE BTech programs, 7 PG programs including MBA and MCA. In the academic year 2021-22, we are going to induct 2 more new UG programs, namely Artificial Intelligence and Data Science and Computer Science with Business Systems. KIT is an autonomous institution accredited with A grade by NAC, and 4 of our UG programs, namely Computer Science and Engineering, Electrical and Electronics Engineering, Electronics and Communication Engineering, and Mechanical Engineering, are accredited by NDA. To bring out the inner talents and ideas of our students, we established a center which is called Dr. Vidya's Incubation Center in the campus. Through this center, the innovative projects of our students are funded by our management every year up to 5 lakhs rupees. Apart from this, notable number of our students' projects are funded by different funding agencies, especially from Tamil Nadu State Council of Science and Technology. Last 3 years, 6 of our students' projects are funded by Tamil Nadu State Council for Science and Technology. Many of our students' projects are won the prizes and accolades from different organizations such as Smart India Hackathon Award from Ministry of HRD, IIT Pulse Innovation Award, Best Projects Award from IIT Kottayam, etc. At the outset, I welcome our respectable founder chairman, Through Pongalur N. Palanisamy sir in absentia, and our vice chairperson ma'am, Mrs. Indu Murugesan ma'am. Without their effort, we would never achieve this excellence. Welcome ma'am. On behalf of KIT, Technoloty Institute of Technology, and the renowned scientist, Director Chandrayaan-1, Chandrayaan-2, Mangalyan, Vice President Tamil Nadu State Council for Science and Technology, Chairman NDRF, Nam Kovai Mandin Mainder, Padmashri Dr. Mailsamy Annadurai, popularly known as the Moon Man of India, to inaugurate this webinar. Welcome, sir. I welcome the resource person and scientist Dr. K. Ramachandra, former Director, Gas Turbine Research Establishment, DRDO, Government of India, former Director, NDRF. Welcome, sir.
Thank you.
It is my great pleasure to welcome our friend Dr. V. Dilip of Scientist DRDO, Director, NDRF. Welcome, sir. I extend my warm welcome to our beloved Principal, Dr. N. Mohandas Gandhi, sir, Mr. Mukund Kumar, Assistant Manager, Technical NDRF, Deans, HODs of various departments, Professor Dr. S. Santi, Coordinator of this webinar, faculty members, and my dear students. I welcome you all once again for this webinar. Thank you. Good luck.
Thank you, sir, for your cordial welcome.
Thank you.
May I now request Dr. N. Mohandas Gandhi, Principal KIT, to offer the presidential address.
Thank you, ma'am. A pleasant morning to one and all present here. Esteemed chief guest, eminent guests of honors, our vice chairperson, madam, vice principal, deans, HODs of various departments, faculty members, and my dear participant students, a delightful morning. I feel honored to be associated in this webinar with the 3 great technical leaders of our nation. At the outset, I thank Dr. Mailsamy Annadurai sir, Chairman of NDRF and Vice President of TNSEST, who is joined with us for inaugurating this event. A recipient of Padma Shri Award, skill has made many historical change in the space science. We have with us Dr. K. Ramachandra sir, former Director of Gas Turbine Establishment, DRDO, Minister of Defense, former Director of NDRF. He has contributed for great initiative in space engines and launched several science and technology, especially in gas turbine. We are honored to have Dr. V. Dilibabu sir, being a scientist in DRDO and Director of NDRF. He is the first Indian defense scientist to get recognition in Six Sigma Black Belt by American Society for Quality Management. It's our good fortune that we have the collected expertise gathered here to educate and train the young generation on multidisciplinary and interdisciplinary approach to handle innovation in academic projects. The purpose of great institutions is to educate and train the young generation to play key roles in our nation. Dear students, I am sure that today's session will help you to stretch your strengths and to achieve your goals. Thank you.
Thank you, sir, for your most eloquent speech. The goal of education is the advancement of knowledge and dissemination of truth. We have with us Dr. V. Dilibabu, sir, scientist of DRDO and director of NDRF, with the multiple post-graduations in aircraft engines, business management, and literature. He holds a PhD in production engineering from NIT Trichy. He has rich experience in R&D and manufacturing of defense aeronautical structures. Being a proponent of technology for common man, he is instrumental in guiding budding engineers to carry out techno-social projects in southern states of India. He has to his credit the international certification in quality management and Six Sigma. With this brief introduction, I now request our eminent guest, Dr. V. Dilibabu, sir, to offer his felicitations.
Can you unmute me?
You are audible, sir. You are audible, sir.
Audible?
Yes, sir.
Yeah. Yeah. Respected Padma Shri Dr. Mailsami Anadresar, Dr. K. Ramachandra sir, Mrs. Indu Murugesan, Madam from Kalanyar Karunanidhi Institute of Technology and our team, dear participants, special invitees from engineers and NDRF, good morning to you all. National Design and Research Forum is glad to present this event in association with KIT on the apt topic of multi-disciplinary and interdisciplinary and innovative project ideas and opportunities for engineering graduates. At the outset, we know the situation we are in. Presently, the nation is going through the second wave of the pandemic, while other countries, for example, Japan is going through the fourth wave of the pandemic. So, though the situation is grim and is challenging, also it has got, it had brought along with it a lot of opportunity.
So sorry to interrupt, sir. Hello, sir. Sir, your voice is muted, sir. Hello.
Sorry for the interruption. Check the audio, please.
Sir, your voice is muted, sir. Hello, sir. So sorry for the interruption. So kindly unmute yourself. Hello.
Sir, Dilip, sir, sorry for the interruption. Kindly unmute your audio.
Fine
Now
now?
it's fine, sir. Yes, sir.
Fine, sir.
Yeah. Okay. So this pandemic brought challenges as well as opportunities. There is a saying that when the situation gets tougher, the tougher gets going. Okay. So many R&D innovative products have come out. As I name DRDO's 2DG, DRDO's medical oxygen plant, ISRO's portable medical oxygen concentrator, or some of the few products. I would like to mention a little innovation happened here. Usually, COVID patients, when the situation aggravates, they need oxygen breathing. So usually it's based on the oxygen saturation level, the flow of oxygen to the patient is controlled. So it actually requires a constant supervision, vigilance on the patient about his real-time oximeter reading and physically.
Sir, Dilip, sir, again sorry for the interruption. I think your audio is again muted.
Now is it fine?
Yeah, sir.
Yeah, there is some change. Change automatically. It is getting to mute mode. Okay, right. So recently we had, a couple of months back, we had a demo at our NDRF, wherein a student had designed a robot for cleaning drainage systems. So students can innovate. Students can bring their bubbling ideas to solve the problems of the society. And world over, student projects have evolved and become a big business entities. For example, Google was a student project from Stanford University. Similarly, Facebook and FEBEX were student projects. In India, also we had lots of student projects turning into become startups and becoming a big business vertical. So, my dear students, take serious interest in today's topic, which is multidisciplinary and interdisciplinary innovative project ideas and opportunities. Take serious interest, interact with the speaker at the end of the session, and we have the apt speaker, Dr. K. Ramchandra, who had 35 years of experience in various fields of science and technology. So I thank him for immediately consenting to address all of us. And this webinar is on the topic of project. We have legendary project director who handled the India's first lunar mission, Chandrayaan-1, and he was the program director of India's first interplanetary mission, Mangalyaan. So we have the legendary scientist with us to inaugurate the event. With this opening remarks, I thank the team of KIT led by Mrs. Indu Murugesan, Principal Dr. Mohandas Gandhi, Vice Principal Dr. Ramesh, and the coordinator Dr. Shanti, who made this event possible, and all the student members and the special invitees from the Institution of Engineers, Board of Governor team from NDRF, and technical advisors from NDRF. All of you I thank for all of you to joining this, and I cordially invite all of you to this event. And also, I am very grateful that Dr. Mailsamy Annadurai is with us to inaugurate this event. Thank you very much.
Thank you, sir, for enlightening us on various innovative projects and startups. Now, an administrator of eminence who is known for his landmark contributions in any of his projects he has handled is our Honorable Chief Guest, Padma Shri Dr. Mailsamy Annadurai, sir, Chairman of NDRF, Vice President of TNSC-ST. With a PhD in engineering, our eminent chief guest joined ISRO in the year 1982 and made incredible contributions for more than 60 satellites made in India. As the project director and program director of ISRO, his significant achievements led to launch of list of internationally reputed satellites like Chandrayaan, Mangalyaan, series of INSAT and GSAT satellites. Popularly known as Moon Man of India, our chief guest has led more than 3,000 scientists and engineers as the director of ISRO, a technical leader par excellence and an international space scientist. He has received more than 100 plus awards, including the most prestigious Padma Shri Award in the year 2016 for Science and Technology from Government of India. As a multifaceted personality, a great orator, writer, and a humanitarian, our chief guest currently holds the responsibilities of Vice President of TNSC-ST and Chairman of National Design and Research Forum, NDRF. With this long list of achievements, I request our distinguished chief guest to inaugurate the event.
Yeah, thank you. Thank you very much for the intro. At the outset, I want to make one small correction. Today's chief guest is not me. I am only the enabler, me and Dr. Delli Babu. Today's chief guest is Dr. K. Ramachandra, and he is a well-known the scientist, and he is senior to me. And actually, as I told, I worked under him in a forum that where VTU, he was chairing the academic council governing body. And so that way, I think he is apt today. And especially when the new education policy national level we are discussing, and new expectations are coming for the new generation engineers, especially post-COVID, as Dr. Delli has told. Today, COVID is giving a challenge for our day-to-day healthy life. But notwithstanding that, I think humanity will overcome this, because even much bigger than that, plague, flu, many things, I think, smallpox, like that, humanity has overcome and it has come back. But after coming back, even to come back itself, engineering has helped a lot. Yes, health workers are there, but still, even to test it, diagnose it, then even to make the vaccine in the large quantity, reaching that vaccine to so many people, tracking the people who are all the pandemic, how to do. I think a huge why even today, even crematoriums, a lot of engineering works going on. So it is a huge efforts even within the COVID engineers are doing. But beyond that, post-COVID, it's going to give a totally different challenging opportunities. So that's how today's the budding students who are going to become the engineers in the coming years, how they can get themselves coped with for the upcoming challenge, how they can make use of the challenge so that they can become a better engineers of tomorrow. Towards that, the topic of especially the multidisciplinary and interdisciplinary approach for innovative academic project ideas and opportunities for engineering graduates. I think that the topic has been taken now. And the NDRF is trying to enable such discourses among the students, such that how you can identify a problem, because doctors are not only with the classrooms, whatever they studied, because it is for this ailment, this medicine. I think that's just one-to-one match alone, knowing alone is not enough. You must be able to understand what is the issue of the particular patient and how we diagnose it, and how then you go for the medicine or the therapies, or something like that they are trying to do. Similarly, the engineer also, it is not just for the engineering graduate to become an engineer. Definitely, one of the main things beyond learning the theories coming in the various class lectures and the examinations you are showing you have done well and you have understood well, and that is one portion. But another portion is how you translate what you learn, how you translate what you learn into a product so that you are ready to be an engineer tomorrow. I think that is the way that the project works have been identified in the various classes. But that way, you look at here, you look at today, I'm standing here purely because of projects, as Dr. Deliva told. But not because of project director of Chandrayaan Mangalyaan. I have not become overnight project director of Chandrayaan Mangalyaan because the back in the colleges, how projects I have done. Okay, I think that is the one which made. Believe me, in 1980, when I completed my BE, it was 1980. So, yeah, in Hindu science column, there was one line came. There will be a day wherein, the photos are hanged in the wall, televisions may be hanged. It was really striking because those days televisions with the big cathode tube, it's a very big thing in the drawing rooms. But how it can be small, okay? Like that we thought. But then when it came to the lab, the CRTs were, oscilloscopes are there, no? CRT oscilloscope. When somebody is trying to make a TV like that, why can't we make an oscilloscope of a smaller version? I think that is the idea. Believe me, my BE project work is a handheld LED-based oscilloscope. Then 1980, nearly 41 years back. Whether it worked or not worked is different story. Okay, but totally different things happen. But that is how what can be done. That means what you see in the outside, how you can translate what you can do, then how you do. I think that's your true compare. Fast forward when come to the ME again. It's a PSG. I think all my studies, I think full and full made in Coimbatore. The project work is basically something similar, 1982, a multidisciplinary approach. Okay, that means I am electronics engineer, electronics graduate, postgraduate I am doing that. So, institute those days, PSG Institute is known for making lathes, but they were trying to graduate into is it possible to go a numerical control lathe in indigenously? Then definitely they need the people from electronic side. So then I chipped in there, working with another set of mechanical students, putting together our group made a numerical control lathe 1982. Okay, that means existing lathe, how it can be converted into numerical control lathe, bringing in the stepper motors, that 3-axis servo controls, many things like that. It has been done that to make a Fresnel lens to cut it for a DST project. It's happened there. So the multidisciplinary approach. Say when then with all this background, when I landed into ISRO, all my discussions are with these two project works I carried. What I studied in the network analysis, or the microprocessors, electron devices, all kept aside. My scoring is kept aside. But all the questions what came to me, okay, in ISRO, for nearly 45 minutes I was interviewed on these two projects alone. Okay, and that is the one which made me to enter into ISRO. And that is down the line it came there. That means project. I was full and full. Today, Milesama Annadhurai was made from scratch to where I'm teaching here in the name of the take-off projects. So, just I understand the importance of the student project in your study today. So, today, Dr. Ramachandra, when he talks about, you take this is an initiative. Okay, that means tomorrow you want to be something big. 20 years from now, 25 years from now, do not wait up to that. Today, I think 5 years from now, you can be something great because the nation is expecting a much faster way, the new engineers, the new ideas, many things to come. And that you do, definitely you can do faster. Fast forward, just come to last year, in the midst of the pandemic, you know, Dr. Ramachandra knows, Dr. Libabu knows, we made for the DST a bit, along with the students and the industry, to another big project itself, multidisciplinary project. And DST funding didn't come, but still with the industry, the idea of the students and ourselves put together, They funded, and that is basically the student project of IIIT TDM of 5 students, a multidisciplinary approach, and nearly 2 crore for the money has been given for the project to do. And today the project has been delivered. Not only project has been delivered, 2 days back, with all the 4 students together, we had the startup company open. Okay, how this has taken just a matter of 6 months of their project work, converted into a product. The product is now ready to sell, and the commercial the vendor is ready to buy, and we are a startup now. So this is shows a ample opportunity in spite of being everybody talks about the pandemic, all these things. I think it's a great opportunity opened there. So looking at these examples, how you can fit in while doing in the Kalanyar Karnanidhi College itself. When you are the various groups, starting from Aero, you are going from MBA, artificial intelligence, data analysis. I think data analysis opens up a big change of thing. Today's, I think even elections are fought not by the people. Elections are fought by the data analysts. They are giving the way how to go about, how to approach, even the today's pandemic, how to approach, where the hotspots are there. A lot of work is made in that. So a huge amount of opportunity. Artificial intelligence is another domain where along with electronics and data analysis put together, it can give a good number of things. So the opportunities are good, but it's all up to you what you want to do, identify the problem, and how to do comes later. Okay, first of all, you do what, then how. While doing a how, it may or may not fit into your discipline, 100%. But still, the multidisciplinary approach, interdisciplinary approach will enable you to make a product of that category that will have a good impact. Not only the product will have a good impact, will take you to the all the way. So that way, tomorrow you want to be an engineer with a meaningful, not only your earning, your name also to come behind. I think start today, listen carefully, Dr. Ramchandra, whatever he tells. And this is basically, he is now connecting between what has happened, one side gas turbine, and I think he's also working for the drones. I think good amount of activities the drones are coming. Possibly with the new government, we may have a big revolution with respect to drone is concerned. I know KIT also is entering into that drone thing. And you have good opportunity. If you can entrepreneur there, there's a good possibility with a drone operator, you can be an entrepreneur in various ways. It's possibilities exist. So with this one side opportunity is available, another side, how you can do that, if it is known, I think you can do wonders. So with that, my best wishes and happy to be part of the today's session while inaugurating this. And now the floor, I think Dr. Ramachandra will be introduced, and between you and Dr. Ramachandra, I am not behind. You make use of the time effectively, so that your subsequent days in KIT is much more useful. So make you to be one of the great engineers what India needs tomorrow. Thank you. Thank you very much.
Thank you, sir, for sharing your profound knowledge on interdisciplinary projects. Now I invite Mr. Mohant Kumar, Assistant Manager, Technical NDRF, to introduce the eminent chief guest of the day, Dr. K. Ramachandra, former Director, Gas Turbine Research Establishment, DRDO, and Ministry of Defense, former Director of NDRF.
Okay, ma'am. Thank you, ma'am. Now I would like to invite the speaker of this webinar. Dr. Ramachandra is a leading aerospace mechanical engineer, consultant, a chartered mechanical engineer, and was a director of the Gas Turbine Research Establishment under the DRDO of the Government of India, and was a former director at NDRF Bangalore. He has over 35 years of R&D experience and 8 years of teaching and training experience. He steered the Aero Engine Kaveri for the light combat aircraft with a project outlay of 3,000 crore and a marine gas turbine system 18 megawatt rating and a small gas turbine of 300 kgf thrust class. Under his leadership, many major certification test facility required for the certification of aero engine were set in the country. He is the one of the most he is the one of the architects of the airworthiness certification process. He had a significant role in development and testing of indigenous accessories, gear drive, box, gas turbine engines for the pilotless target aircraft, jet fuel starter of the light combat aircraft, and the winged engine for unmanned aerial vehicles. Dr. Ramachandra has supported many MTech programs, and as one of the founder member of Rapid Typing Society of India, he is the president of the Bird Strike Research Group of India, and has introduced the concept of the foreign object damage and mandatory damage tolerance design of the complementary aero engine. Dr. Ramachandra is also deeply involved in the development of the fixed wing, rotatory wings, flapping wings, and mini micro aerial vehicles. So now I would like to invite the speaker, sir, and please take this virtual stage and please address to the students, sir.
Okay. Good morning. Am I audible, Mukund? Am I audible?
Yeah, sir. It's you are audible.
Very well.
Yes,
okay.
sir. Yes, sir.
Thank
Audible.
you. Very well. Thank you. Once again, thanks for this invitation to be a part of this wonderful event of a webinar, a virtual webinar with the students of the KIT. And I must thank NDRF, the chairman, the director, for giving me this opportunity once again. This is my privilege and pleasure to be a part of this. I extend my welcome to the entire administration of the college, of the institution, the principal, the vice principal, the deans, and the faculty members, and of course my own colleagues in NDRF, the board of government members, and of course all the technical advisors who are present in this webinar. Now let me start with a presentation without much ado, and start with a PPT presentation. It's going to be a rush job because I had a few thoughts which are collected. Now, can I share this PPT, Mukund?
Yeah, yes, sir. Okay.
There you go. Is it visible? Is it?
Yes, sir.
Yes. Okay, very well. So let me get started, and I think it's going to take about 55 to 60 minutes, and I'll rush through this. And once again, this was written down, so I repeat this, but then this is thanks to the chairman, and it's my privilege, and I welcome all the students of this institute, and not to forget the organizers, the administration of the institute, the entire faculty, the principal, the vice principal, and the management personnel who are there. And I wish the students who are in the final year doing the project all the best and a very bright future. And again, greetings to all the faculty members. Now, the focus of the seminar, Dr. Dilip Babu and Dr. Anadure have already given a brief background of what it's all mean, the purpose of this seminar or the webinar. And this is a very similar version of the webinar I had with several academic institutions. It sounds very repetitive, but I want to drive home the point that today it is simply, as Dr. Anadure was mentioning, Dr. Dilip was mentioning, it's simply a multidisciplinary and interdisciplinary focus, attitude that the students have to develop. And particularly in the context of the challenges which are there due to the COVID-driven online classes and projects being done far away from the institute, it's going to be very difficult to approach the laboratories and the industry to support you. And therefore, we need to really look at the priorities and the actual realities we have post-COVID, as Dr. Anadure was mentioning. This is not only for the immediate project execution, but as a career for each one of you, we need to really look at this. I will go through some examples of multidisciplinary and interdisciplinary projects. Not that you don't know, but I just want to highlight the significance of some of these things. As Dr. Dilip Babu and Dr. Anandra were again mentioning, demand breeds opportunities, and we need to be aware, to be conscious of the opportunities around us, which we normally forget, and leverage them to make best use of whatever we can. And so, if you look at post-COVID, there is a big focus shift. I mean, this is what everybody's been telling. This is an era of innovation, startups, incubation centers, and tinkering labs. And today, the healthcare, agriculture, and societal applications have become much more important and unavoidable, and a major need for the country. And therefore, we need to look at that. And as in NDRF, we've always recognized the need for networking, sciences, and engineering. So biological sciences, agricultural sciences, medical sciences, including social sciences, they need to be integrated with engineering. And that's normally not happening in a big way, but I think we have no escape. We need to be doing that. And today, agriculture is a major issue. Farm productivity, increase in the farmer's income, marketing for the farmers, they all are major focal areas for students and for the engineers who are there. We will also have a quick look at some wind turbine energy applications, and more importantly, automotive vehicles and environmental issues related to automotive systems. And then I'm very happy that I'm also going to address a few aeronautical engineers of the Institute, and therefore we have a few aerospace applications. And when you talk about healthcare systems as one of the focal areas, at least today, we have a very bad idea of healthcare system. I think we think it is a relation between the patients and the hospital through a doctor. But actually, it's become relevant. It's become so important. It becomes so visible today that it's not just these two elements, but all other things, which includes the pharmacies, pharmaceutical industries, extended care facilities, including laboratories which do a lot of work. It is expanding because of the COVID, for example, today, and it will happen. And we need to integrate the company issues like sectors like insurance company. The whole gamut, all put together, is today's healthcare system, and we need to recognize and see how we can play our role in this. A few initiatives in the healthcare system is not that I'm telling for the first time, but today the healthcare system has to look at least about 60% of people who are in remote areas, who are inaccessible. Just an example, if you look at Himachal Pradesh, around Shimla, the city of Shimla, we have around 60 to 100 kilometer radius. We have people who have no access to medical care. And if they have to get a testing done, it takes 4 or 5 days of hard work for them to go up and down. And imagine such a thing happening in snow-clad winter days of Shimla, Himachal Pradesh. And today we are using very in the initial initial phase, the task of taking the samples, blood samples, urine samples, and any other medical samples from the remote areas, or 60 or 70 kilometers into Simla's lab, and within a day the results come out, and we have apps which tell the patients and the local doctors what to do for the next step for medical attention. Now today we have, this not in India alone, everywhere this is the case, and in fact including the developed countries and areas in Africa. You can see one of the examples which is seen here. It is it's a fixed wing, very rudimentary drone, which is catapulted to go at least about 150 kilometers and deliver very quickly medicines which are required for people who are far, far away in inaccessible areas. So this is the power of the drones and the medical care system. If it is planned properly, all this can be done. I recall very fondly the work which we did in NDRF a long time back, maybe 4 or 5 years back, in developing a non-invasive glucometer. You can see the one at the corner. This was developed, but it takes a lot of effort to put them through medical certification process. But this is what happened. We took about two years to develop this. But if that can be done why not today in today's context, all the facilities, non-invasive systems and user-friendly, patient-friendly gadgets, medical devices, which may include even non-invasive malarial and tuberculosis systems. There's a lot of opportunities. The reason why I'm mentioning this here is it is not alone. I mean, it's not medical sciences alone. It is a lot of engineering. And this particular thing has delayed because we are not able to productionize it. We need to make it compact. We need to make it affordable. And there's a lot of engineering which has to go into this. And that's the reason why I'm presenting this as a case. Now, there are issues of accidents in an urban situation. I can see a lot of remote areas, people get into medical issues, emergency issues, and we have the rural area accidents. And if you have the GPS-based systems, and if the drones can be summoned to that location, and if the drone can spot that location and see the condition of this, it can immediately alarm the police and the medical systems to approach, to come quickly into this. They can easily take care of the so-called golden hour and see if the patient, if the accidents, the victims of accidents are going to be needing any particular help. That can be handled within a short period of time. Otherwise, we don't know where they are and how to locate them. All these things can be done by the system. And imagine this is another serious case. This is not a real versatile, I mean, a case where everybody is affected, but there are emergencies, medical emergencies where organ is transported from a donor in a donor hospital to another city. Maybe if you take the two examples of Bangalore and Chennai, if somebody is going to donate an organ and to take it to Chennai within a couple of hours, it takes enormous effort to today's context, because you need to take the organ, put it into a container, and transport it to the nearest airport or a railway station for that matter. A railway station may not be the case, but an airport. And you need to therefore stop the traffic and create what is called a green corridor. You can see what's really happening in a city, and you have to empty it and allow the ambulance to take it to the airport. And you fly a commercial or a chartered flight and go to the destination airport. And it's the same once again there, is to be repeated. But the important thing is these organs have a very small shelf life when it's being transported, maybe 2 hours, 3 hours, or 4 hours. And therefore, we need to develop drones. We know drones, but we need to develop drones to be able to handle this sort of payload, a very critical payloads, a medical payload, and fly from one hospital to another hospital, across cities, across rural areas, and within good time. And these are some of the projects which are going on. And you can see the X-copter, which is able to carry, for example, 20 to 25 kilograms of payload. Payload being the container in which heart or a lung or a kidney is packed, and it is transported in a passive way. And you can see that this particular thing is the container, which is a passive container where the heart or the organ is kept in an ice box, and it is sanitized, medical sanitation fluid is there. But this, when it's transported, is good only for about 3 hours. It is kept at about 4 degrees centigrade, but this is not good enough. Whereas if you use another type of active container, which is called a perfusion container, where the organ, like heart, is pumped with fluid, blood-like fluid, or blood itself, as sanitized fluid, and if it's kept active, pumped, and therefore the heart keeps beating, and it's again kept at about 4 degrees centigrade. But it's not a passive container, but an active container. These the devices are there in the hospitals today in the operation theaters. But the challenge is, can we make them small? Can we make them affordable? And can we use it for lifting in a drone? This is the challenge. And therefore, the case for a group project of multidisciplinary and interdisciplinary project. It is not interdisciplinary within engineering fraternity. It is engineering, biomedical engineering, and medical, the doctors themselves. So it is, I know it's a very difficult job for the students to do independently, but it has to be supported at the institution level. Already there are a couple of projects around, but I think we need to put in a lot of effort all over to be able to achieve this target of an active perfusion container, which will take it'll make the heart, the organ, healthy, keep it healthy for about 12 hours, not just 3 hours. Which means what? It can be transported from Delhi to Trivandrum, and it's possible to do that. Today is a very difficult task to do that. To do a flight, to charter a flight is very expensive. It talks about 20 to 25 lakhs to do that, maybe 12 lakhs to do that. And therefore, it is something which you must do. And talking in the same frequency, we are talking about as an immediate future, the bioprinting of a product of organs. Now, we have done a lot of work. I'm sure Dr. Dilip Babu understands this very well, or most of your faculty members understand the advances that were made in 3D printing process, not only plastics, but metals. Today, we can make engineering parts, aero engine parts, automobile parts in metal by this process of 3D printing, which is directly from the CAD model to a product, which is done by layer. And this is something which we are all comfortable with today. A lot of advances has taken place. But the question is, can we do that? And this 3D printing is able to do a lot of things, including very funny, the low-end food processing and making food products. But can we extend that to the other end? Can we print biological organs, maybe skin tissues, maybe parts of an accident victim? What is shown here is an earlobe, for example. Can that be done? It may be outrageous to talk about this today, but you must be realizing a lot of work is already going on, and we are far behind already. And we need to catch up. You can see, today people are able to do skin tissue. The basic process is basically to introduce a skeleton, the scaffold, they call, and that gives the shape of the part into which the medical, biological processes are introduced, and you mature the product, and it becomes a living tissue. It is like a biological part, like a part on our body, and this is possible. And there is a lot of effort going on in a complete heart or a kidney, which is, you can look up literature, and at least 2 or 3 startups have started in India, and a couple of institutions have started this work. And I think we need to look at this possibility of bioprinting. We have been talking about this for a very long time, but not much progress is done. And since you have people with the medical colleges around in the engineering, around engineering colleges, why not try but it cannot be again done in one go. Rome was not built in one day, and therefore you need to start somewhere and put some mechanism of bisecting this. You decompose it to doable small elements of work and connect them up to come up with a technology which can do this. This is not really a big emergency today, but unless you start today, you will not be able to get into that. So we'll get back to agriculture technologies. And when you talk about agriculture, the usual idea is it is paddy, wheat, and sugarcane, what you normally do grow in a conventional agricultural products. It's not so. It is horticulture, it is forestry, it is more importantly aquaculture and animal husbandry. All this come under agriculture. So we need to see how to help the farmers. We're not just farmers on the field growing paddy and wheat, but doing all these things in the field, in the agricultural field. Now, there are several things that needs to be done. One important thing that I want to highlight, I don't want to spend a lot of time on this big loaded slide, but I just wanted to just say one thing about the food storage systems. We grow a lot of things with difficulty, but 30% of that is wasted because we are not able to store them properly. in proper cold storage systems, and the silos which hold grains, for example, 30 to 40% is eaten away, is spoiled because of the environment, and it is also eaten away by the rodents, and then the spillage, and not alone pilferage. So there is a lot of thing that needs to be done. Can we have silos, not the Food Corporation of India silos, huge ones, but even smaller ones, which are there in the village communities? Where can we do a small silo in which grain can be stored? Can we control the temperature? Can we keep the grain agitated continuously? And can we control the humidity so that the grain, the stored materials last for a long time without getting spoiled? This is one example. And there are a lot of issues, a lot of things that can do with reference to monitoring of locusts, shooing away the locusts from affecting the agricultural crops. And there are several things. We'll go one by one. But the important thing is, just where do you start, where do you end? There's a huge plethora of activities, starting from the soil testing, the sowing of crops, and spraying pesticides, and then warding away insects, crop damage, handling floods, how to handle floods, and then, of course, quite a bit of agricultural activities which come in. I don't want to go into the details. I'm sure the students, you're all smart these days. You have seen a lot of work going on in the use of drones for agriculture. But today's limitation, as far as my experience goes, is the availability of the payloads, the camera systems and the telemetry systems that are necessary for making the best use of these drones. And to give an example, the high-end camera system, the LIDARs, I'm sure Dr. Anandare would be knowing all this in very, very great detail, but I just want you to put some thoughts in what are LIDARs, how do they help? You can see the photograph from a LIDAR, and when you process it, what really happens, what is seen is something amazing. So use of LIDARs and maybe hyperspectral cameras, multispectral cameras, etc., are real requirements. And you must therefore see and increase the versatility of use of drones for several agricultural application, urban scenario, urban governance, and so on. So you must look at these camera systems. Just as a matter of information, here is a clip which we developed out of a hexcopter, which we developed long back with by NDRF at NDRF in collaboration with an academic institute. It is able to spray 5 kilograms of thing, but it's manually done. So if you put in some artificial intelligence into that, it can recognize what your plants need, what type of insecticide, what is the density of insecticide or pesticides or fertilizer. And all this can be done automatically by an intelligent, more intelligent drone system. And this is something which is very important to augment the capability of drone systems by infusing artificial intelligence to make the best use of the resources that we have. Now, here is an example of a drone, which is not the conventional drone which you all know. I'm sure some of you might have studied this already. It is a hybrid drone where the drone is like in an helicopter, or if you like, it's very similar to a sea harrier. It takes off vertically using these propellers. It takes off vertically up, and once it goes to a certain altitude below, about say, today's context, 200 feet or 60 meters, it dashes. So it has got the advantage of both helicopter, rotorcraft, as well as a fixed-wing aircraft. And using this, it is possible for surveying a large area of agricultural tract or an urban scenario at a particular height. And this is something which you must be able to do. There are a lot of issues involved in this. As the aeronautical engineer, some of you will understand the effect of the transition between going up to a particular height and dashing off. That transition between vertical lift and horizontal thrust is something which is very interesting, a good challenge, and you must be able to do. Several workforces, groups have already started, but why not start this? And one important aspect of the drone is use of drone itself. And if you say an agriculturist, a farmer, who normally in our situation owns very small holding, he's got few acres of land, he can't afford to have this system and operate them. You should have a training to do that. It's not readily available. So why not service provider models like Uber and Ola you, as engineers who understand these systems, you own these drones as many as required. And like the combine harvesters and tractors are being used as cooperatives in northern India and maybe in southern India as well, you can have drone operating systems which can be used for several applications, maybe for land survey, maybe for spraying, maybe for any other agriculture purpose. But you lend your services, take the responsibility for operating this, and then you help the farmers to do their farming very effectively. So this is a Ola and Uber type of operation. Why not engineers take this initiative? And it is not necessary to have drones only in cities, in urban scenario. It has to percolate down to remote areas where it is required, but they're not able to offer, they're not able to operate. So what is the requirement for this? You need to have certified agri-drones, agricultural drones. It has to be certified. DGCA will not allow you to otherwise operate. So how to certify drones? You need certified drone pilots. You become trained pilots, trained operators, and then believe this, and I'll come to that in the next sheet, next slide. If you run a drone for survey, if you run for an hour, you need to process the data which you gather, and that is at least 5 to 10 hours of hard work using software, the data processing software, and your skills. So that is the scale of operation. After is not just flying a drone for collecting data. The processing of data and giving it to the user is a major and important activity, and we are not able to do that. Today's drone operations are limited by limitation of the software and the operators of the software itself. So this is some of the things you must really realize. So you have this, for example, you can per day with a quadcopter, you can run about 200 acres of survey and collect data. But we can only, with one or two systems, we can do only 100, half of the data that you per day. You need maybe even less than that. So you need to therefore look at the total system that's required to complete the operations and help their farmers to do their job. Now, from the typical agriculture to aquaculture, there are a lot of issues with aquaculture. Aquaculture is the cultivation of, for example, of fish and prawns and the other marine products. Products. And then, important thing about the aquaculture today is the water quality. Water quality, if it is bad, if it goes bad, within a day or two, the farmer, the aquaculture pond operator, loses several crores in 3-4 days, and that's terrible loss. And this is not acceptable. And therefore, we need to continuously monitor the quality of water. Today, we don't have good facilities. We take sample water from the boundaries of the aqua ponds, or you take a boat and pick up some samples, wait for 3-4 days to get this water quality parameters tested in a lab. So why not, therefore, have autonomous water sampling, water monitoring, water quality monitoring systems? And also, why, if something goes bad with the water, what sort of chemicals should be sprayed? So sprayed or added to the water, and can you use oxygen, aerate the water to mitigate this water quality depletion? So these are some, and this is particularly very important because a lot of labor shortage, and therefore, can we do a couple of things like that is the issue. Now, if you look at today, these are the ponds, typical thing spread all over the coastline of the country. You have a huge business potential. A lot of people are doing very, very routine, mundane type of work, but the profits are very high, but the losses are also at times very high if you don't maintain the water quality. And therefore, how to do that is something which we thought about. This is one of the projects which we did in Andhra Pradesh, and this is a small little joy boat, two-seater boat, which was converted to as an autonomous boat to monitor continuously the water quality, not just at the periphery of the pond. It may be a 20-acre, it may be 10-acre or 5-acre, but this boat can be programmed. It is an autonomous boat which has got sensors dangling below into the water, and it gives you, it senses the pH value, temperature, dissolved oxygen, ammonia, and nitrates. And we can also fit in video camera, underwater photographic systems and transmitters, which can look at the feeding habits of the fish and prawns. It can see the growth and health of the species, and also see if they're infected. And therefore, we can have controlled, I mean, this is monitoring altogether. So you have a boat which is now autonomous, not dependent on anybody, any labor, but it is programmed to work around entire surface of the pond, not just the specific locations. And this is something which has been done. A snapshot of this is here, and you can see it is moving. It's moving on a programmed way in a small demonstrative pond, very small pond, but this can be extended. This is, of course, a thing which is programmed. It is driven by a battery system, and therefore, to make it more versatile, can we convert that into a solar powered? You can see the hatch, the top surface, can be with solar panels, which will make it self-sufficient, at least for the daytime. It will not have to depend on the battery. So it is a very, very innovative stuff. And as a please believe this, Army is looking for such autonomous boats for coastal surveillance. Once you have this thing, it can be done in a bigger scale to meet the Army's requirements. There are several different applications, but here is an autonomous boat which was developed in an educational institution, and this is, of course, needs to be taken further. And then this is the schematic of what I was telling. This is the boat on the surface of water on the pond, and below that boat is the sensor suite, which takes the sensors to measure pH value, dissolved oxygen, nitrates, ammonia, and temperature. And this is processed either on board or it is processed outside. And this data can be through your app reach the respondent, I mean, the owner of this pond, and tell him and warn him, there is a problem with your pond. You please do attend to this quickly. What is the problem? Is oxygen is depleting. What do? You must have aerators. You must increase the number of aerators in the pond. So a lot of other prescriptive decisions can be taken, and it can be stored. Important thing is, it is not only the information to the farmer, but entire area. The fisheries department can be fed with this data of which are the ponds, what are the problems of water quality in the area, and all this can be fed back. So if you find that water quality is good, the farmers today actually use paddles on the periphery of the ponds, whether it's 20 acres or 2 acres. They touch only the periphery, and using paddles driven by IC engines, they keep agitating the water. It's a very crude, very symbolic. Water quality is not going to be improving very drastically. They're doing it, but some of them managing. But to me, it appears, as an engineering person, you would expect a lot more practical things to do. Why not having a floating boat which paddles, which is there, and it's programmed to move all around the entire surface continuously, including night. So you have a 24/7 water aerator, which does the aeration or introduction of oxygen into water by this particular system, which is again a demonstrative version, and therefore it is noisy. Sorry about that. You can see it is paddling. It is an autonomous boat driven by batteries, and we have a solar panel. And this, the initial work needs to be completed and maybe brought into a production level. And this is what I was saying. Here is that boat which is paddling here, and this is disturbing the surface to introduce oxygen. But that may not be good enough. And therefore, why don't you have a pump which draws water from below the boat and puts it out as a geyser, as a fountain, and the air goes, the water goes into air and picks up oxygen and drops. So we have a boat which is moving, which is paddling here, which is also pulling out water and aerating it in air. But at the same time, can I not also use a compressed air, compressor, to push the atmospheric air into water at certain depth, very gently, not to disturb the fish and the prawn in the pond. And therefore, you have aeration below water surface, on the surface, and in the air. So you have got a very effective, highly effective oxygenation, if you like, the aeration of the water pond, of the aqua pond, and this is something very, very, very useful thing. So you need to look at innovative ideas to increase the effectiveness of the system. And can I add also the water quality monitoring system, including camera system. So you have a very comprehensive aquaculture autonomous board to do a lot of things at the same time. Imagine in the area, several of them, in each pond there is one such board, and they're all connected to the fisheries department, to the owners of the ponds, and you have a very happy situation where you can do. It's not just confined to aqua pond. This idea can be extended to look at the nuclear radiation levels of either seawater or ponds in and around nuclear zones, near nuclear power plants. And there's a very high possibility the radiation levels will be high. Can we not monitor in addition to oxygen levels, temperature, the gigamole counter, which can track the the nuclear radiation levels and also the temperature? It is important that the nuclear reactors do not pass very hot water into the surroundings. So the temperature and the radiation levels can monitor, and this can be even augmented with underwater vehicles. Today we have a lot of underwater vehicles which can be programmed to work with the boats, these surface boats, to do this nuclear radiation levels safety monitoring, coastal areas, and in and around the nuclear power plants. And this is something which is very important. We're talking about underwater vehicle. There are a lot of autonomous underwater vehicle technologies. They're being developed, being studied, and they're being trying to be made affordable in the system. Here are some of these snapshots of several types of underwater vehicles. Most of the colleges, I suspect even KIT may have an underwater vehicle program. But the important thing about this is their utility, their usage, how to make them very usefully used to achieve certain objectives. Now, the important thing for this is ability to communicate. Can you control the path of this underwater vehicle? Most of them are tethered. They can go up to 100 meters by a cable which is connected to a controller. But can it be made autonomous? And how to communicate with the drone which is below water, from a controller which is above water in the air. So the communication between the air medium and the water medium to make this move around the way you want and do the tasks that it is expected to do. This is something, there are a plethora of very useful underwater vehicles, and I think we need to launch this sort of vehicles with reference to several things. Can we study marine biology? Can we study the land erosion? More importantly, can we study using this, the safety of structures, the ocean structures? This is an oil drill. You can, quite a few of them sort of collapse because of local rusting and the forces due to the waves. And it is a very difficult thing to inspect these structures continuously through divers who go down and take pictures of this. But if you have the underwater vehicles, they can be made to continuously run and capture images of critical locations in the structure. And therefore, the application, you have the vehicle, but it's not the end of the program, the end of the idea. Idea is to use it usefully to complete a very difficult task very affordably. So this is something which you did. Now, I was talking about the water quality monitoring of aquaponds. It is not necessary to have only moving vehicles, boats and underwater vehicles. We can do a simpler job using buoys, so floating spheres, for example, BUY buoys, which will have ability to sense water quality and then also have internally power supply, internal power supplies, and the camera system. And if you have a small buoys or spread all over the aqua pond, and if you connect them all together, you have achieved the target. You don't have to have a very complex moving objects. So what is a buoy? This is being done by the NIOT, the National Institute of Ocean Technology. They have huge buoys for maybe tsunami monitoring in the ocean, in the seas. But this smaller version of these buoys spread on aqua ponds can be used for monitoring the quality of water and the health of the fish and a prawn in the. You can see a buoy which is there. It has got sensors which can be immersed into water and pulled out if required. It's got its own battery system. It's got data processing and also a solar panel to make it more user-friendly in terms of power required. And this is something which is affordable, and it can be done by several students as a batch. So this is something which I thought I should mention. The use of buoys for aquaculture. We have many societal applications, which is not high-end, but important thing, which are really required for day-to-day work. You can see the civic amenities, the ambulance, firefighters in the urban areas. We have the application of drones, and then of course there are a lot of issues with industrial areas and urban cities, urban areas for pollution monitoring, and of course the weather monitoring, a lot of environmental monitoring. So this needs to be done. Here is an example which is already available. You have mobile library systems which are there, to which you can go and pick up, but they are not really user-friendly. It is not, in today's context, a lot of people are not able to move around. It is aged population, and they may not be even able to move around. So can they have this facility, library facility at the door on command, on request? Smaller one, it may not be big library, but they give you a preference. It is like the apps that we have for delivery of like Swiggy or Big Basket. You have this facility of reaching reading material, books and magazines to the elderly, to the deceased, people who cannot move out. And this is all based on technology, app-based technologies. And can we also have pharmacists visiting houses on demand or in a routine? This is something which is happening, but it needs to be made user-friendly and things like that. Today in Tamil Nadu, this is already available in a big way. Mobile medical services, Mananalam, Workinalam. You know, the caption itself says all. But can this be done in a smaller but more effective way? You have cancer detection. Today, COVID inspection, COVID testing is becoming a serious problem. People are not willing to go out. They can't go and get it tested. But you have a mobile system. It knocks at the door. Every home who are willing to get tested can be done more effectively. And this is something which is a big problem in cities. It may happen it is happening definitely in Bangalore and Chennai. I'm sure it's starting to happen in Coimbatore. And these are the firefighters and ambulances getting struck for hours together in traffic. So why not have an app, a possibility of a system which is given to the driver of the ambulance who controls if you're struck, the lighting system, the traffic management system, and clears his way by suitably changing the control lights, the traffic lights, the way he wants to make the traffic clear quickly, and then hands it over to the traffic management system once he crosses. This needs to be given to the ambulance driver or the firefighting driver who knows what is the situation on the ground, and instead of depending on the police to clear the traffic, which takes enormous time, he handles the traffic signal, which is one of the main reasons for such a big traffic jam in cities. So this is something which you must think of. And can we have small systems? Today, the pollution monitoring in industrial areas and in cities, we have maybe 8 to 10 mobile monitoring system moving around continuously at designated times and designated points. And can we use, therefore, drones to have the sensors, the nitrous oxide, particulates, and carbon monoxide, many other pollutants, which can be sensed by the drones which are moving around all over this town, including the industrial areas, and continuously monitoring and feeding back this information. The pollution level depends on the day of the time of the day, the night or daytime, and the vicinity, the wind direction, and so on. So all these things are it's very difficult to monitor with just a few mobile road vehicles. So this is a possibility that we can monitor pollution through the swarms of drones. So two things: we need to carry the sensors appropriate and be able to transmit it to the IMD, the meteorological department, and you must be able to avoid collision, because you're flying in a very densely populated areas and you don't want to collide with each other. So the collision avoidance system is a major requirement for this operation. And then sensors needs to be the proper sensors. And then this can also be done with other applications. We'll come to that a little later. I just want to shift focus to something called seaplanes. Seaplanes are planes which take off from water, they land back in water. They can also take off from land and land on sea, or take off from sea and land on land. So they have a very versatile amphibians, if you like. And this is something as students, you must be very, very happy to have this study. It's basically a fluid dynamics study where these vehicles have combined both aerodynamics and hydrodynamics. When they are on water, they've got both hydrodynamics and aerodynamics. When they're airborne, they're completely aerodynamic. So there is a combination of both fluid mechanics coming into picture. And I refer to this seaplane in this context. If you look at our country, there's a huge, vast coastline. And there are about 13 major ports and about 185 minor, maybe more now. So there is a possibility. But today we don't have access to the minor ports. It's very difficult to go to these places. Commercial activity is not possible there because of connectivity problem. So can you not hop from one end of the coast sequentially across the coastline using seaplanes? As a country, we have done very poor. Elsewhere, a lot of seaplanes helping passenger traffic and traffic and the goods management, goods traffic. And that's something which is possible with these sort of seaplanes. If you look at, we won't go into the details, but there are two types of seaplanes. One is the flying float plane. It is an aircraft, or maybe a small aircraft, given for an example. This could be a two-seater, it could be a 10-seater, it could be bigger. But they are provided with two floats. And they use these floats for landing, taking off from water. And this is the other one is a flying boat, which is a boat, actually regular boat converted to aircraft with the addition of wings and superstructure, and of course the propulsion systems. So these are the two types. And if you look at students, you must understand why we are talking about seaplanes. They are supposed to be comfortable, ecologically friendly, which may or may not be economical. It should be economical as compared to typical, I mean, time-wise, it's going to be much more economical. And I am not too sure about this less noise, but unless you sit. But what is important is the access to remote areas that do not have runways for normal planes to land. The greatest advantage is runways are not required for their use. Now, I can foresee from the city center in Coimbatore, for example, from the airport, you can have a seaplane ferrying passengers and luggage from the airport to the local pond. It takes a very, very small area of a pond to land. This is advantage of seaplanes. You can see the specific feature of the seaplanes. I don't want to discuss go in the physics of this, but it's a wonderful, wonderful subject to study. As aeronautical engineers, as mechanical engineers, and even as control engineers, there are a lot of things to learn from the way these seaplanes work. It's a shame that we are not done in our country any effort to put in. They have commercial value. They have they can be passenger traffic, passenger traffic, and also the tourism. In fact, from Bangalore, within Bangalore, we have several lakes, and it's possible to connect Bangalore city center with the airport. It's about 10 to 15 minutes of flight from the airport. Otherwise, it takes 1.5 hours today to trek, to commute between the airport and Bangalore city center. So there is a lot of things that needs to be done. More than this, it is this issue which is important. You can see that the seaplanes is a major requirement in urban scenario for urban and even forest fires. And these seaplanes have been extensively used, apart from helicopters, for dousing forest fires. But in our context, urban fire is a major thing. Today in Bangalore and maybe in Coimbatore, we have very tall buildings. If there's a fire, it's very difficult to reach the top floors, the top of the building. And within the traffic system that we have, you are going to waste 1.5 hours using both firefighters and ambulances and reach the spot. So this is something which should be done. This particular seaplane, for example, takes about 10 minutes to suck water from the pond, 6 tons of water, and reach the spot in about 15 or 20 minutes of flight within urban scenario, and douse the fire, dump this 6 tons of water within 15 minutes. Can you imagine that happening with the normal firefighters? You can't have 6 tons of water, and you can't reach the top of the building. So this is something which you must do. And why not initiate the development, understanding of the seaplanes in the colleges? We can see one of the typical amateur projects. It is a seaplane which is carried by a person. So it's a small one. It is a small thing which is being flown by amateurs. And the important thing is it is landing, which is a very difficult thing. Now, therefore, is it not possible for the college to support student projects to develop technologies for sucking water while the seaplane is taking off, or when it is stationary, and demonstrate the possibility
Raman, Dr. Ramachandran cut off. It looks audio went off, no? Dr. Ramachandra is not online, or I don't know.
I'm asking to person. Mukundam sir? Mukund sir? Sir, Ram sir, kindly unmute yourself, sir.
Audible?
Yeah, now it's audible. Now it's audible.
I'll put the picture. I have to start sharing the
Yeah. Just some 2 view graphs have gone, I think.
All right.
Yeah.
There is some clutter, I think. I'm audible now?
Yes, sir. Yes,
Yeah,
sir.
towards audio.
Are you able to see the slide?
Yeah.
Okay, so this is what I wanted to tell. The institute should support this sort of activity where you can demonstrate the mechanism to scoop water from water body and take during takeoff or before takeoff and jettison in flight. So this is something which I thought I'll mention. But then let me go back to one slightly different topic, the wind energy system, which is not fully exploited in my opinion. We are not talking about big wind farms. We are talking about the ability of developing small power through small wind turbines, that is vertical axis wind turbines. If you look at the scenario, this is a slightly older slide in terms of the statistics, but we are in the middle or the fag end of the ability to manufacture small wind turbine, install them, exploit. We have a reasonably good wind conditions in the country. We're not the best, but still we have a lot of things to exploit. And this is something which you must use. And we are talking about small wind turbines, not the horizontal axis. We are all aware of what's happening, but the vertical axis wind turbines. I mean, people have extreme views about this, but the vertical wind axis has the unique advantage that it is not dependent on the wind direction. So it responds to any wind direction, and therefore amenably suitable for developing 3 kilowatt, 5 kilowatt, 10 or 15, 20 small little power, which can be used. And this advantage of this thing is it can be networked. It can be on top of the building. It can be between the buildings, in front of the building, on the ground, and they all can be networked to develop. It's very, very suitable for small village communities or even urban communities. An important thing about this is, again, we can use the vertical axis wind turbines along with the solar. So it's a hybrid vertical axis wind turbine supported by solar power. Therefore, there is a possibility. We've not done enough work in understanding. We have taken a very extreme view of, no, they're not suitable for our country, but that's not true. We need to be sort of assessed properly. Quickly, a few things on automotive and aerospace engineering. I'm very happy that the KIT has an aerospace or aeronautical engineering department. I'm sure some of them will appreciate and look at this as possibility. Now, if you look at the automotive sector, it's a very sad thing that none of our cars, our indigenous cars, actually have passed the crashworthiness test. And in fact, the type of material that you use, the protection that is required, the energy that is to be absorbed due to impact, and protect the passengers is all a matter of economies of scale, and the economies of production, and the type of material that we use. And the bottom line is, none of our cars have been able to do that. So what to do for this? And therefore, we need to do. In fact, I was remembering the work that I did for Siemens in looking at the crash of an automobile car similar to the four-seater, shall we say, Maruti car type of thing, and slightly bigger one, and finding out for the requirement of crashing, the speed at which it should be tested, the value of G, the deceleration value, where it's the most optimum to put in a sensor and trigger the airbags, because if you don't trigger it in time, you are triggering the airbag safety bags too soon or too late. So it is going to be very, very troublesome. It's a lot of work that needs to be done to understand the strain energy response of the system, and also protect the passengers. Now, when you talk about protection of the passengers won't be there in the car while the car is tested, actually, understandably. But we need to develop, we need to have passenger dummies, instrumented passenger dummies. And it looks so simple, it looks like a toy, but actually it's a typical example of a multidisciplinary, interdisciplinary product. Each one of them, the man and the woman and the child dummy, is a conglomeration, is an assembly of all biomedical properties, the bones, the blood, the skin, and the stiffness of the system and the way they respond to all these things is all put into this model, and it's instrumented. And in fact, each one of them costs about 2 to 3 crores, not lakhs, crores actually. So it's a very expensive system, and we have not done anything to develop these things. Whether we should develop or not is a major philosophical question. People show away taking a decision on that. But as a technical challenge, we have a need for this. We need to prove our cars, and we need dummies for that, and physical dummies. You can create virtual dummies. That is something which you can do start first. Virtual dummies, which can be put into a virtual model, car model, and use them for testing and see how these virtual dummies respond to a car crash, car frontal crash, car lateral crash, and so on. But to do this, we need the help of doctors, we need the help of mechanical engineers, materials people, and all sorts of disciplines, including control system guys should come in. And we need to launch a program to develop virtual passenger dummies and physical dummies in the years to come. It never happens tomorrow. It needs to be planned and done today. So a second part of the automobile is today we are talking about e-governance. Governance, everything is going to be by 2030, 2020 is the target, but even if it's 2025, everything is going to be electrical power and no diesel engines or IC engines. Therefore, but today it's limited by the duration, the endurance of the battery, which can allow the car to maybe run for about 100 kilometers and then a charging. So charging station and bigger power batteries is an important thing that is to make it happen by 2025 and 2030. But in the meanwhile, as an intermediate stage, can we not use automobile range extenders? We've been working on this range extenders, which is nothing but a gas turbine or an IC engine-based charger, which charges the battery when need. You're starting the vehicle in Bangalore today and you're going towards Chennai. Continuously, the battery level power is being monitored. And whenever it goes below an optimum level, this range extender kicks into action and it starts charging the battery to bring it to a comfortable level. So this range extender is based on IC engine or gas turbine. A little pollution is there, no doubt. It is the antithesis to e-mobility, but the range extender is an important element because today it is limited by maybe 200 kilometers or 300 kilometers, but big trucks have to run for thousands of kilometers. So can we not think of a viable range extender, very little pollution, but ability to charge batteries and make the range of the automobiles go from today's limitations of an average of 100 kilometers to 1,200 kilometers as you go along is the question. So this is possible today, and it's been done. The second part of the same thing is, today in the COVID condition, we are afraid to sit in a car with the AC on. We don't want passengers to be affected by the pollution and maybe virus that is likely to be picked up on the way. And therefore, the cars are all no AC, doors open, windows open, and this is not good. And it's not going to continue. Like Dr. Another is telling, what after COVID? Do you keep the doors when the windows open? No, not at all. Today, you look at the big aircraft, 500 passengers, 300 passengers, 100 passengers. They claim with the filtration that they have, they can get 99 point something percentage of virus-free air into the cabin, into the system, into a passenger hold. And this is possible in an aircraft. I mean, if it's possible for an aircraft, why not for a car? Why don't you make a smaller filter and retrofit it into the existing? And lakhs and lakhs of cars are on the road. So there's a huge business potential if you're able to develop a clean filtering system and can be retrofitted. Of course, it's going to affect the engine performance. It's a back pressure created, and you would probably use a little more fuel. Fuel efficiency will go down, but at the cost of good filtration and virus-free and maybe bacteria-free environment, maybe a dust-free environment. Why not? In fact, today, if I don't use the car for a week and start the car, if you put the AC on, it's not very comfortable. So all these things can be handled with a good filtration system to be retrofitted to an automobile. So why not? Why not that one? So if we quickly go into some aerospace applications, today's drones, we have done a lot of big drones, a lot of very versatile drones, but their operation is limited, curtailed, because of the lack of payloads, the high-end, high sensitivity, high-end camera systems and transmitters, and the onboard processors. Now, here are some examples I'm giving you. A few industries, very few industries have started, and some educations, maybe some IITs have started working on these camera systems, which includes the hyperspectral, multispectral, thermal IR cameras, plus the LIDARs. So we need to have indigenous. Everything is being imported. Import, if we have anomaly, we have to import. But how long can we continue importing? You may be restricted, you may be arm twisted. So we need to prepare ourselves. There's a huge void in the payloads for the drone systems, and that we need to do. And when you talk about drone systems are developing in a big way. A lot of applications, a lot of useful things. We are going to coax DGCA to allow us to fly the way we want without compromising the safety of the drones. But today, somebody is going to misuse the drones. They're already using it, and you can see a lot of scare around the globe. So we need to identify. You can't allow unregistered drones, unregistered pilots to operate these drones. They may have bad intention. They may wreck your urban scenario. I mean, they may put in some explosives and do that. So can you identify drones which are not registered, which are, you must have the friend and foe identification system, and then identify drones which are not. It's a very difficult subject, but I'm just trying to postulate the requirements. And then having spotted them, how to neutralize them, how to bring them down safely, capture them, bring them down safely. And if we cannot avoid through spoofing, jamming, can you neutralize that? Already we have technologists in the country, high power lasers, electronic medium, which can damage, which can completely wreck unwanted systems. So why don't you miniaturize them and use them for handling anti-drone technologies for drones which are not which are rogue drones. And similarly, we have the issues of bird strikes on the aircraft, and this is a very, very important subject today. No flights, no problems with bird strikes, but it's going to be a major, major issue. It is already a major issue. It's not the single bird, but a huge block of birds. And we don't want these birds to be present in strategic areas in the airport, for example. And if we don't prevent birds, and this is what is likely to happen. You have seen several examples, and I'm sure it is topmost in your mind. But then today we are trying to use these drones to carry scaring devices on them and prevent birds from getting into the precincts of the airport. And maybe 10 kilometers length, about 4 or 5 kilometers width, and about 2 kilometers height is the volume into which you don't allow birds. So if you're flying these drones outside the area and scare birds away from the airport volume, it's a major, major miracle that can happen in handling bird strikes. You can see already the system. But what is required? You need to fly these drones to spot birds and scare them, to take them away from, not into their airspace, but away from their space. And this needs acoustic devices which can create noise, and birds don't like it. And you can have lasers to scare them away. And more important, the lasers, very funnily, birds are not blind. They're very sensitive to, for some good reason, to blue and green radiation laser, blue color lasers, and you can carry them on board the drones. And this is a virtual, a preliminary thought, and this needs to be given a shape. We can also use user-friendly, environmental-friendly chemicals on the drones and make them move the birds away from the system. Therefore, this needs an ability to spot birds and approach close. And there's a lot of issues are involved. I just wanted to present the philosophy, the principle on which this can be handled. Now, it is not good to talk about, shall we say, vintage technology. And vintage technology is the overcraft. This is overcraft, which is an amphibian. It can move on land, it can move on water. but it is not in touch, it doesn't touch the water or the land. I'm sure most of you guys know about this. This is a very old technology. It is a 1960 technology. As a matter of fact, this is the technology which Dr. Abdul Kalam was working with as a first project in ADE. What really happens in a warcraft, you have a fan which sucks in air and pushes this down, and it creates an upward thrust along with the skirts, which you see at the end all around. These are the skirt. And this pushes the warcraft above. And then you have a floating machine, which is used for transportation of goods, transportation of people, and it's pressure time tourist attraction. So why not look at this? But people ask this question: why are you going back in history? Why are you going back into yore? And it's not really. Today, if you look at the coracles that we use in BC for crossing rivers and streams, and this is the left-hand side is the situation. But this can be made safer and much more pleasurable if you have smaller these amphibians which can be developed. And so why not have a system which can be developed in a college and demonstrate it can be done very effectively? And they have a lot of applications. In fact, in the flood systems to help NDRF, I'm talking about the other NDRF, there is the National Disaster Response Force. If they have these small hovercrafts, it will help the job much, much more. And it also has recreation. And of course, the military use is there, and there's a mass transportation possible. So hovercraft is something which aeronautical systems, aeronautical engineers can really look at as a laboratory experiment in itself. I mean, I'm not talking about a project. So there is a good chance that we will have hovercrafts in the application. Other applications, I'll skip some of them because I think I'm running short of time. So the alternate to the batteries, which are limitations for endurance of the drones, is the fuel cell. Today's fuel cells are very expensive, first thing. Second thing, they're bigger, and therefore can we use miniature versions of the fuel cell? There's plethora of fuel cells, but you must be able to select and miniaturize the right type of fuel cell. Already you can see there are fuel cells which are there on high altitude drones to give them longevity, the endurance, which is really required. So some work, initial work, which is chemistry, chemical engineering and mechanical engineering, power engineering, if you like, they need to be started. And fuel cell, in my opinion, is something which is a lifeline as far as we're concerned. We are talking about automobiles. So you can see that there are already these bigger vehicles which are used in mini fuel cell. And the automobiles, the batteries are very limited in terms of power, that is power density, the rate of charging and rate of discharging. So if you use fuel cell, it's going to be adding a lot of positivity to the e-mobility which you're talking about in a big way. So fuel cells and automobile. Fuels, miniature fuel cells and aero applications are the things. Therefore, we must concentrate, must look at fuel cells as an area of research, of development. A lot of things have been going on, but without much success because the foundation is not there. It is not being impressed upon students to take up these tasks. And there is a very, very important pressure requirement for this sort of thing. And I want to end up this thing with a very last set of slides. And I'm sure Dr. Anandray will be very familiar with this. He must have done a lot of these things already. We have a need today of high altitude, long endurance platforms. We had a couple of student exercises, competitions, and design reviews. And there is a need for this platform. And what is this platform? Before going to that, we already had demonstrated, the students and engineering colleges have demonstrated their ability to integrate themselves, multidisciplinary, interdisciplinary within the colleges, and many colleges coming to the as consortium models, and you have developed lots of satellites which are being launched by ISRO, and that's a great thing. In fact, very recently, about 10, 15 days, maybe 1 month back, we celebrated the launching of 3 palm-sized satellites by the recent ISRO launch, and Dr. Anandray was also there. And this is our ability, students' ability, the college's perseverance to do these things. And if that can be done, why not this? why not the high altitude, long endurance systems, platforms, which are basically high altitude, long endurance aerial platform. Army is interested. Civil applications are there. So why not launch programs like this? And what are we talking about? These HALAPs are pseudo satellites. They are very similar to satellites, but altitude is very low. They are in the stratosphere and approximately 25 kilometers altitude, but they must be able to carry about 100 to 150 kilogram payload, which the defense systems or the meteorological system, for example, can use. And they must hover at any design station for a few weeks, and not a few hours, few weeks, few days. Now, for example, HALAP, this platform can be started, can be launched, say around Balasore or Calcutta. And then it can follow the coastline and reach maybe Kanyakumari or Chennai and stay there for about 4 weeks and monitor what's happening on ground in the naval system in our Indian Ocean, and then go into the Arabian Sea, go to that place, maybe Bombay, maybe in a pre-development thing, or you can go to the coastal, the theater of war, for example, and be there for another 4 weeks or 6 weeks and gather information on what's happening on the ground. This is something which is for coastal and land asset surveillance, homeland security. More importantly, weather forecasting and disaster management. What's really happening on the ground with reference to floods and things like that. So these are already available, but we have not started in a big way. We can see different varieties, the different platforms. It is actually a lighter than air system, and this is a propulsion system, which is electric battery operated with solar power, and another version of that. There are plenty of them available already, but we have not started. We need to make a very small beginning, and this is the Army, the Defense Service is already interested in quite a way, and I'm sure there will be a civilian application spin-off for these applications. So one challenge that we must immediately start and take up further is the high altitude long endurance aerial platform as a small little activity associated with the large canvas of ISRO activity. And I think we should give a preference to this. And this is not impossible. If we can move satellites and launch them through ISRO help, why not just start working on these systems is something which I wanted to do. So that is a rush job of telling whatever I had in mind to tell you. What you need to do is to exploit the potential of any of these ideas or any similar ideas, any which comes to your colleagues and your faculty. We need to exploit them to reach, to go to the societal, to have societal and business potential. And this project to be selected by the students cannot be the whole thing in one time. So it has to be a part of this small system, and but ultimately they should all lead to technology and product realization. An unsolicited advisory, as Dr. Anadre was mentioning, you must have relate all the things that you study in the classes to applications. Unless you do that, you're simply learning rote. There's no point. You must change your outlook to become multidisciplinary and interdisciplinary, and think out of the box and think of the big canvas. What is the end objective of the small thing that we are doing, and how it ultimately reaches the end solution is something which you must have. And focus on realizable innovation and futuristic technologies, which should be driven by societal requirements. And what I suggest, I'm sure from what I heard from the principal and the vice principal, you're already doing a lot of things, but you must make it more. You must passionately take part in national and international product and design competitions. And I'm not too sure. I'm not in the education administration system. I'm sure you have a honors degree, and I think you should aim at it. Not because it is honors degree, but it pushes you to the edge, makes you think and train yourself much more vigorously to get a honors degree if you have the system in your mind. And therefore, one important thing as a piece of advice or suggestion to the institution is you're already doing sirs and madams, but I think we need to do one important thing. don't have projects which are over in one go, in one semester, final semester. One project is taken now, is different subject, another project of a different type. You are spreading the resources too thin. I think you must identify maybe 4 or 5 teams and stay with that for 4 or 5 years and have batches of students working on the same themes for a long time. And then only you achieve a product, a technology, and you can make the institute shine with those products and technologies. Otherwise, you are simply running away with doing little things and not adding this outcomes into a technical accomplishment. So this is all I want to say. I'm sorry I burst your time margin, but you must pardon me for overlooking that. Thank you. Thank you very much. I'm done with. Hello?
Yes, sir. Yes, sir. Yeah.
Okay.
Thank you, sir.
Thank you, sir.
This is nothing but thank you. With the bookshelf symbol format, font.
Thank you, sir. Thank you so much for your words of wisdom on inter and multidisciplinary project. I'm sure it will be really an eye-opening session to our budding engineering graduates.
Thank you.
Now it's time for the interaction session. Dear participants, if you have any queries, get it cleared from our eminent chief guest during this interaction session. Before your questions, kindly click on hand raise option, mention your name and you can ask the questions.
Ramya Bharati.
Yeah, Ramya Bharati, yes. Go ahead. Am I audible?
Yes, sir, you are audible. Ramya Bharati, ask your question.
I probably didn't get the message. Yeah.
Okay, the other student, please.
Preeti, you yes, please ask me.
Preeti, right.
Unmute yourself and ask questions, no?
Maybe she has not unmuted.
Yes.
Okay, yes, sir, I think. Mr. Shiva.
Make sure that you are giving permission to them, because all of them are forbidden to start. Only that, yeah, we are lifting, yeah, that's the issue.
Please unmute
Yes, sir,
yourself.
yes, sir. Harry, you check it kindly, please.
Yeah. Shiva, you can ask your question now.
Sir, can I ask the question?
Yes, Shiva. Yes, please, Shiva.
Sir, I want to be a startup. I want to start a startup. So, நான் வந்து ஒரு tiny projectல வந்து நான் என்னோட knowledge improve பண்ணிட்டு நான் அத சேல்ஸ் அது மாதிரி இன்க்ரீஸ் பண்ணலாம்னு இருக்கேன், ஐடியா பண்ணலாம்னு இருக்கு சார். It's a tiny project.
Sorry, Shiva.
The problem society.
Yeah. Right. No problem with that, Shiva. What I think, since you are not too sure of what you want to do, Naketa, you just have a chat with NDRF. At NDRF, we will tie up with you and see what you have in mind and propose something which is suitable for your background and what you want to do. So we can have through NDRF a discussion on what you want to do. You're most welcome to talk to us at NDRF or individuals, and we will try to pick up the tabs and help you as much as you can, as quickly as you can. Adu pannalam, no problem.
Yes, sir. நீங்க based upon நான் வந்து இங்க டெல்டால இருக்கேன் சார். ஸோ ஃபார்மர் இஷ்யூஸ் வந்து இங்க நிறைய இருக்கும். ஸோ அதுல வந்து ஏதாவது நம்மளால டைனி ஹெல்ப் வச்சுது அப்படின்னா ஸோ வி கேன் இம்ப்ரூவ் அவர் ஹெல்த் அண்ட் ப்ராப்ளம் சால்வ் பண்ண முடியும். அதான் சார் என்னோட பேசிக் ஐடியா சார்.
பண்ணலாம் சிவா. அது வந்து கொஞ்சம் டீட்டெயிலாக டிஸ்கஸ் பண்ண வேண்டியதாக இருக்கும். ஸோ வி வில் ஹாவ் அ சாட் இன் NDRF. யூ ப்ளீஸ் மெயில் டு டைரக்டர் NDRF ஆர் டு மீ. வி வில் ஹாவ் அ லுக் அட் இட். பேசலாம் அதை பற்றி.
Okay, sir. Thank you for the information.
Okay, it's good. Another student, please.
Sir, good afternoon, sir.
Good afternoon.
Yes, sir. Thank you, sir. Sir, I have one question, sir. Sir,
yes.
Sir, in nowadays, sir, there is a 21st century, sir. There is a many students are not have a courage, sir, and they are not have a long-term thinking, sir. My question is, sir.
Yes.
Sir, there is a difference between the students, sir. Students comes from after the college. They are not ready to do that. Something, sir. I said that. Sir, there is question is there is students are having very little dreams, sir. They have to just come college and have a place in a good company. There is focus is having a 10 LPA per annum or 15 LPA. There is like their dreams are has been ended, sir. Sir, my question: what is that lacking from the students from the nowadays in the engineering students, sir? What is that lacking? Why are they not come up, take a courage and take that? And even we are only acknowledged by the after that webinars. They are telling that we have to do that projects and something, sir. Then after we are not there in our not my institutions. I simply saying they are only focusing marks. Students should score a good marks, then they can easily groom their lives. So there is like a, even though we are what I'm saying, that webinar they are all said that this important, that important, but your students are not encouraging or not appreciating to do these whole projects, sir. We are not
okay.
Yes, sir.
Okay, you wait. Our scientist will give you the reply. You wait, please.
Yes, sir.
Professor Ramesh, can I respond?
Yes, sir.
But the problem is, of course, a lot of things are, it depends on the outlook of people. If you want to get into, there are three possibilities. You can get into, for example, a job situation. You don't want to go into higher studies, or you may not even want to do an personal entrepreneurship. So your focus may only be getting a job and get going. To get a job, you need to have naturally a basic score, but more importantly, you should be able to communicate. You should have the right aptitude and attitude. But then if you see if you recollect what Dr. Anandre mentioned in the very beginning, the project plays a major role. You may not be able to communicate well, but the proof of a good project done by your student friends and yourself is a major sort of proof that you have the ability to meet your employer's requirement. You may not be able to communicate very well, but what you have done as a project, the outcome of the project, a report of the project work that you've done is an indicator, that a proof. So whether you're a good communicator or not, whether you fared very well or not is a second issue. But most important thing is to pick and choose with the help of your mentors in the college or outside and do a reasonably good, and you must be fully engaged with that. You must feel one with the project that you do, and you must do. That's one of the important things. You may find it difficult to pick up information from webinars and seminars or discussion, but that's where your mentors come into picture. So you must have a detailed chat or with your college mentors or your other well-wishers, and pick and choose your friends, group them up together and do a reasonably good project. And if you concentrate on that, your natural ability to tell what you've done comes in additionally. So, and parallelly, what is important, whether you like it or not, you must improve your ability to written communication and oral communication, which you will, of course, the college will support you through the personality development programs and so on. So there are several issues that you must do parallelly, and I'm sure if you want to do, you can always do. This is what Dr. Anandre said, and I repeat what he said. Thank you.
Okay, sir. And any other questions from the students? Okay, Nitya ma'am will conclude.
Yes, sir.
Okay.
Thank you, sir, for solving our queries devotedly. Thank you so much. Now I request Mr. Mohand Kumar, Assistant Manager of NDRF, to propose the vote of thanks. Mohand Kumar, sir.
What is the okay.
Mohand Kumar, sir. Can you propose the vote of thanks?
Mr. Mukund Kumar.
Ma'am, he is not in the meeting.
Okay, ma'am. Ask our principal to propose vote of thanks, ma'am.
Yes. I now request our principal, KIT, to propose the vote of thanks.
Good afternoon to all. First of all, I thank Dr. Ramachandra, former Director, Gas Turbine Research Establishment, DRDO, former Director, NDRF, for giving detailed explanation about what are the projects, how to initiate the project, how to make the project. So, in this regard, I thank Dr. K. Ramachandra for giving detailed explanation. I also thank our guest, Padmasri, Dr. Mailsamy Annadhurai sir, for giving detail about how to start a project. So that for starting the project, the students should have determination. First, they should have vision, how to initiate the project. So he explained. Then they should have determination till end for completing the project. He explained in detail. I also thank Dr. V. Dilip Babu. He gave detail about how to select the project which are having social impact, social value. So whether it may be less cost or business motive or very less eco footprint and material saving, like this. He explained so very good social impact project, how to select the project. Thank you, sir. I also thank our Vice Principal, sir, for giving the warm welcome to all. I also thank Nithya Madam. So once again, I thank Ramachandra, sir, so for giving the detailed explanation about the project, how to initiate the project, with giving various field, starting from agriculture and aeronautical, how to select the project, giving the examples, how they can do the project. So thank you, sir. Last but not least, I thank our Madam, Vice Chairperson Indu Murugeshan Madam, for motivating our faculty members to do this type of webinar to enhance our students' knowledge. Thank you, one and all.
Thank you, Professor.
Thank you,
Thank you, ma'am.
Thank you, sir. Thank you, sir.
Yes, that's the end of the session. Here we conclude the remarkable and memorable event. On behalf of KIT, I thank each and every one of you for sparing your valuable time in nurturing the young minds. Once again, thank you to each and everyone. Thank you.
Thank you, ma'am. Thank you. Thank you.
Thank you, ma'am.
Thank you, ma'am. I will sign off. Thank you. Good day.
Yes, sir. Thank you, sir.